All right, great. Super excited to bring to all of you the second session of this APAC training series. My name is Siddhant, and you can call me Sid, and I lead developer relations for APAC at Neo4j. Uh, we are here for the second session in this APAC training series. Today we have with us Adam Curley, who's going to talk about intermediate cipher and data modeling. The last session we talked about how to get started with Neo4j, and this is a step forward from there and taking you how to move forward with Cypher. But just before that, let me just give a quick intro about a few things. One second. Well, yes, Neo4j loves the community. A quick intro about Neo4j for those of you who have missed or who are starting now with us. Neo4j as a company, the idea was conceived on a flight to Mumbai. The product was started in 2007. We started with an open source community edition, and then we added in closed source enterprise edition. We launched the Neo4j version 5 last year. I'm sure you're all excited for this session. I'm myself super excited for this one. And if you want to win this awesome Neo4j t-shirt, show us your excitement in the chat window, but also do something, which is make a Twitter post. Tag me, that's my Twitter handle, at the rate Sedagarwal04 and at the rate Neo4j. Use this hashtag graphs are everywhere. I've also added this in the ticker below. Show some love on the comment section as well. All right. Cool. With this, I'll not hold you on further with the next speaker, who is Adam. Hi, Adam. How are you doing?
I'm good. Hey, Sid, how's it going?
Good. The stage is set for you. I'm sure you're all ready with your exciting content on intermediate cipher.
Absolutely, yeah. Looking forward to it. Although I've just lost my my password for my OR instance, so I'm going to make it up as I go along, I think.
All right. While Adam is doing that, make sure, folks, you are tweeting about us, showing your excitement on Twitter and also in the comment section. Yes, I can see the excitement going on. Adam, let us know once you're ready.
Yeah, I am. I'm good. Let's let's go in. Okay, go. Cool. So,
Right.
hey everyone, hey Pack. My name is
Before
Adam.
you start, I just wanted
Oh,
to do
yeah.
this. I really wanted to do this from a long time. Is
Okay.
action. Go on.
Cool. Brilliant. Hello, APAC. Yeah, my name is Adam. I'm a developer advocate for Neo4j based in the UK. I've been with Neo4j for I think about 6 years now, but a Neo4j user for almost a decade, which is scary when I think about it. I actually forgot that it was actually a flight to Mumbai that the concept was conceived on for Neo4j. So that's really cool. Yeah, I remember seeing the Emil's old presentations of the napkin and the drawing on it. I think it was maybe a recreated one by that point. It had been the old one had been lost. But yeah, that's yeah, cool. Yeah, so I think I started to use Neo4j just after they introduced Cypher. So Cypher was the key thing that made me use Neo4j over another database at the time, because I actually really enjoyed writing Cypher at the time. So yeah, I'm really pleased now that pretty much almost a decade on, I get to teach people Cypher, which is amazing. But yeah, we're going to cover that today. We're going to go into Cypher in a little bit more detail, and we're going to look at some of the ways that we model a graph database. So I'm going to start slow so we can go fast. And we'll look at, firstly, we'll cover the fundamentals of graph databases and Cypher, just so we're all on the same page and we know we're all talking the same language. I'm going to show you how a Cypher query actually works, and then elaborate on how we can write performance Cypher, and use some modeling techniques to improve how we how we model the data, and then how we query the data as it comes back. And then we'll go in and we'll start writing some Cypher. So I'd like this to be an interactive session. So bring your questions if you have anything that you're stumped with, if you have anything that you're trying to achieve through a Cypher statement, then we can look at that today. Otherwise, I think I'm just going to play through some example queries and see if we can build up an increasingly complex query using more advanced Cypher techniques.
That's right. Just to chime in over here, folks, just mention in the comment section if you have any questions. We'll pause for a while whenever we are done with one section, and then we can take up those questions at that point of time. But keep mentioning them in the comment section, whichever platform you're joining us from YouTube, from LinkedIn, Bitmarker, wherever you're joining us from.
Yeah, sounds good. Cool. So when I talk about graphs, so hopefully you've seen some sort of diagram like this before. Circles connected by arrows. So this is what we call a graph, and this is building on the foundations of graph theory. So in Neo4j land, we talk about nodes and relationships. You may also have heard these being referred to as edges and vertices. So that's the graph theory angle on it. But really, we talk about nodes, and these are the foundation of our graph. These are the circles that we see in the diagram, and nodes represent things. So in this case, this is a node that represents a MacBook. We identify these nodes by one or more labels. So this is a way to tag nodes, but also to aid the discovery. So we can, find all of the nodes in our database that have a label of product, for example, and we can go in and identify those very quickly. We can use multiple labels on a node. So in this case, this is a product, but it's also a fragile one. So we can use that as a kind of like a binary tagging of a node, or something that we can use for discovery. To add the context to the data in the graph, we use properties. So properties are key value pairs stored against a node. So in this case, this is has a name property of MacBook Pro and a price of 2699. To connect two nodes together, we use a relationship. So a relationship, or any single relationship, connects any two nodes together. They always have a type. So in this case, this is in our context, this customer node has rated a product, so customer to product. We have a direction, which can be ignored at query time, but every node will, every relationship will have a direction. And like with nodes, we can add properties there to add more context. So in this case, this person has rated a product. We have a stars property there of 3. So this is 3 out of 5, 3 out of 10. Not quite sure. And then we have the created at property there, which is a date. And the way that we query this is through, like I said earlier, this language called Cypher. So Cypher is a declarative language that allows you to identify patterns in the data. So in this case, when we talk about a pattern, we're talking about in this case, a person who has rated a product. And we use an ASCII art syntax or star syntax to represent this pattern. So really what we're doing is using text, we're drawing out this pattern. So where we have these circles to represent these nodes in our diagram, we can actually use rounded brackets to signify these. And then we can use a colon to say, to define the label or labels for this, for these nodes. So in this case, on the left-hand side, we have a customer. On the right-hand side, we have a product. Now we use dashes to draw a relationship between two nodes. So right now, this is a valid Cypher pattern, but it doesn't really tell us too much. So what we can do is we can draw an arrow using greater than or less than, or angled brackets. And then we can draw a box around our relationship information using square brackets. So again, we can use the colon to signify the information about the relationship. So in this case, the relationship type. And we're defining here a outgoing relationship from a customer node to a product node with a type of rated. And then to act on these, we can assign variables or aliases. So we're assigning C here to customer, P to product, and then R for the rated relationship. And then we process that or use Cypher to act on these values. So in order to find something in the database, we use a match clause. So we match a pattern. So in this case, we're matching a customer who related a product. And then in the return clause, we're defining what we want to return to our application. So we're returning the name property, so c.name. And then we're giving that an alias of customer, p.name as product. And then r.stars is given that an alias of rating. So from here, we'll get a list of every customer, the product that they've rated, and the rating that they've given it. And if we take a quick, a closer look as to how this works, what happens is when we write a match clause, and this goes back to the declarative nature of a Cypher query. You'll write a query, and then the Cypher query engine or the Neo4j query engine will work out the best way to find that pattern in the database. So in this case, what will happen is it will go away. It will examine the schema. It will look at things like the number of nodes that have a particular label. It will look at the indexes that we have on label and property pairs. In this case, what it will do is it will select the index with the high selectivity. So in this case, we're looking for the customer with a customer ID property of Anton. So this is what we call an anchor node. So we find like anchor nodes or start nodes for our traversal. And then what we do, and this is the secret sauce of Neo4j and graph databases, is that we then start to expand and traverse through the relationship types. So we from that customer, we then find all of the purchase relationships in an outgoing direction. So in this case, in this diagram, there's only one there. And then we take a look at the node on the other end of that relationship. So in this case, we're looking for any node on the end of a purchased relationship which has a label of order. In this case, this is our only one that we've got there. From there, it will then traverse out again. So we're expanding the orders relationships in an outgoing direction from the order to the product. And then we're checking that the node on the other end has a product label. Same again here. We're going through the part of relationship to a category, which here are given an alias of CC. And this is a nice feature of Cypher, is that what we can do is we can say follow a relationship type in a certain direction for a predefined number of relationships until we find the node that we're looking for. So in this case, it will start at the category node, and then it will follow the has child relationships in an incoming direction this time to until it ends up at a category with a name of electronics. So you can imagine, like, if you're trying to do this in a relational database, for example, you have to kind of write a recursive like procedure, or you'd have to write left joins and then check if one or two, like the first or second or third degree table actually had that value there. So that's a really nice feature of Cypher. So that's reading. In terms of writing to Neo4j, we have a few options. So in terms of adding a set of data, or like a pattern of data into the database, we have two options. We have create and we have merge. And then to add information to those nodes or relationships, we can use a set and remove keywords. And then we can use the delete to delete an element from the graph, whether that be a node or relationship. So let's take a quick example. So as a customer, I would like to register for a website so I can buy my groceries online. So what we want to do here is we want to create a customer in our database. So this is what a create statement looks like. So what we're doing here is we're creating a pattern in the database. Now this pattern is only a pattern of one node, but a pattern nonetheless. So we're creating a node here. So we're drawing out the brackets. We're saying that this will have a customer label on there, so colon customer, and then we define the properties using like a JSON style syntax. So inside the curly braces, we can define our key value pairs. Now I mentioned create and also merge. Let's take a quick look at the difference here. So a create statement is used to create new nodes or relationships in a graph or a new pattern. If we have a pattern there that may already exist, we can use the merge statement, which is a similar to like an upsert. So we can I'd like first search for a pattern, and if that pattern is not found, then we can try to create it. So the key point to remember here is we use the merge statement when a node or relationship may or may not exist. Let's take a quick example of that. One thing to remember is that the whole pattern will be created if any element inside that pattern is not found. So this is the common thing that definitely when I was starting, I tripped over quite a few times. It's definitely an important thing for people to remember. Yeah, one thing I have to keep kind of reminding myself as I write Cypher statements. So let's take a look at a bad example. So here we're trying to merge a product node, which is part of a category, which is so the name of beverages. So why is this bad? Well, if one of these elements does exist but the other one doesn't, then it will try to create the entire thing. Two things will happen in this case. Either you'll get duplicates of one of the nodes in this pattern. So say, for example, our category already exists, but the product doesn't. It will try to create a new product node, a new category node, and then the relationship between the two. Now, this will either lead to duplicate nodes, or if we have a constraint there on the category name property, to force uniqueness, then it will basically throw us back an error to say, that one of these nodes in this pattern already exists, so we cannot go any further. The good way to do this is to split this out into smaller chunks. So I've added an extra category in here, but what we're doing is first saying find or create the beverages category, then find or create the alcohol category, find or create a node with a name property of Beavertown Neckerwell IPA, and then either find or create the relationships between the two. And now we can run this statement as many times as we want, and we'll only get 3 nodes and 2 relationships created, because once those are already there in the database, it will just return the values that we already have. So that's creating data. So we can define our properties as part of the pattern, but we can also use keywords to set these properties as well. And I guess two of these nice things that we can do with the merge statement is we can use on create set and on match set to conditionally set properties. So for example, when a node is first created, we can set a certain value on there. So in this case, like a created at timestamp, and we're setting that to the current date and time. If we run this statement and that pattern already exists, then we can do other things. So in this case, let's say that this is we're looking for a product's inventory. Sorry. We can set a restocked product label on there to say that this has been stocked and restocked. It might be interesting for somebody in the sales department to work out which products have been restocked. And then we can set properties regardless of whether that value whether that node or relationship existed at that time. So in this case, we always want to set an updated app property. And then we can use the remove keyword to remove either a property or a label from a relationship. So let's say in this scenario, somehow when the last piece of stock was ordered, we had a little bit of like application logic to say there's nothing left. Add a label to this to say out of stock. We're then removing that in this statement to say, this is this is no longer out of stock. So then we can add it back to our product listing page or treat it differently inside our application. Excellent. So I don't see any questions in the chat so far, which is either a good thing or a bad thing. A reminder, if you have any questions, then just shout them out, and then Sid will pick them up, and we can look at the end of each section.
Adam, there's a question. I'm not sure if you want to take it now or probably later. I'll just let you know. The question is, how can we use knowledge graph capabilities in logistic world? Can we also optimize the whole structure to provide a recommendation to fulfill the demand at the factories or hubs?
That's a tough one. I think we'll probably cover that one a little bit later on. Yeah, that's definitely above and beyond the topics of today.
True.
Yeah, you may have to break that one down for me as well, because that's quite a long one.
Yeah, I was wondering that. I think that should happen later on. But yeah.
Yeah. Cool. Okay. Cool. So we've now kind of looked at the how we look at the data that we have in there, but how do we decide how to model that data? Like how do we decide what is a node, what is a relationship, what is a property, and how do we arrive at something that's going to be performant and answer the questions that we need to answer? So through this, we look for the topic of data modeling. So there's a few ways that we can go about this. We can take a structure that exists in some other place, but the way that I like to start is that I like to derive a data model from a use case that I have. And normally, if somebody's come, like if we're scoping through a project and we want to work out, we have like a set of requirements, or I personally like to work with user stories. So we're going to use user stories here as a case. But really, what we want to do is use like a ubiquitous language. You want to use the language of the business, like domain language, to actually model our nodes and relationships in the database. And for me, the best way to do that is through user stories. So what we can do to decide what goes where is we can extract things out into nouns, verbs, and adjectives. So first we identify the nouns, the describing words. So we could say in this case that we have here a customer. So we're not talking about a user here. We're not talking about a I don't know, a company, an individual. We're talking about customers. So it makes sense to model that in our database as such. So in this case, we can then extract that out to say that we have a customer node in our data model. We also have, so we can derive from that. If someone wants to order a laptop and accessories, really, we like in business logic, we in business language, we call that a product. So in this case, we've got a MacBook Pro there and a keyboard as example of things that we could buy. So we then take the verbs, and then those verbs become our relationships between our nodes. So in this case, a order. So personally, I like to convert these into past tense, because as soon as that data is written to the database, the user has ordered that thing. So I've taken the order verb, put it into the past tense there, and then added that to the data model. And then in this case, I've got a created app property there as well, to show when that's been ordered. And then the objectives there that we have, that they become our the properties that we store on nodes. So we could say really that we can derive from this user story that laptops and accessories, they are categorizations of our of our products. So in this case, we've got, and then we can kind of derive, like take a step back and say, actually, so these are all electrical things. So then we can create our hierarchy of categories into, and then we have the products which are part of those categories. Cool. Now I'm going to instantly break the rule that I've just said here, in terms of using the verbs as relationships. Now, sometimes it might be enough to know that a user has ordered a product, and for maybe for like a recommendation use case, or like if we have a graph of customers and orders, and we want to do like people who ordered product A also ordered product B. It's just enough to know that the person has ordered that product, and we can use that as part of our recommendation query. But there may also be cases where that isn't good enough. And what we can do is we can take that information from our derived model and then extract a relationship out into a first class citizen or a node in its own right. So in this case, it makes sense to group the products that the user's ordered by an order ID, and then that also gives us the benefit of being able to add extra information or extra facts to that. So we can say that this order has been fulfilled by a particular shipping company. Maybe the order was facilitated by a sales representative. So we can start to build out the model from there. Cool. And so one of the questions I get asked a lot is, like, should this be a node? Should this be a property? Should this be a relationship? And so I was a consultant with Neo4j for 2 years before joining the DevRel team. And one of my favorite consultant phrases is, it depends. And it always depends, right? It depends on how you're going to be using this data. So let's take, for example, an address. So this is, say, a payload that's come back from a website. Maybe this is consumed via some sort of messaging queue, or this is just the payload that comes into our application. Now we've got the same address here, which is duplicated twice. So is this a good thing, or is this a bad thing? And again, it depends on how we're going to use that data. So the secret of many database technologies, and I suppose Neo4j is one of these as well. Many databases, they will duplicate data for read time performance, and that's fair enough. And we'll do the same thing. We'll look at ways that we can derive a relationship or use a specific relationship type to make our queries faster inside Neo4j. But if that address is read only, it's never going to be kind of queried through. It's just something that you see in the data. It's used once and then thrown away, is ignored. Store it as a property. It makes absolute sense to do that. It's less to store a property in Neo4j, less disk space to store a property than it is to store a relationship. So it makes sense to just duplicate that data, and then we can just read it back as and when we need to. So if we take another scenario, so are the billing and shipping addresses saved as part of the checkout process? Is it something that's used later on? When I place my orders on Amazon, I get a list of 2 or 3 addresses that I can send things to. In which case, we store that as a node because it's something we're going to read back later on. Maybe we have a customer node, we have a relationship out to an address node, and then it'd be easy to pick out those previously used addresses for when placing the next order. And then are we going to query through that node? So when I place an order, so when I first signed up for my local takeaway delivery service during the pandemic and during lockdown, they were offering like a 10-20% off for your first order. But inside their T's and C's, it said actually that offer was only valid for one or once per address. So what we would do then is we could save the relationship as a node. Then when the next order comes in, we could use a merge statement to find or create that node. And then we basically count the number of relationships going into it. If the number of relationships is 1, then that offer is valid. If it's more than 1, then sorry, you're going to have to pay full price. Cool. And then again, so is this address part of a larger graph? So are we using the graph to optimize delivery routes? Okay, so this is a node as part of a part of a larger network. Maybe the address or the point, the actual the physical location of the house is connected to other houses, and we use that to actually optimize the delivery routes. In which case, we store that as a node. Cool. So that was the way that I like to do things. Let's now take a look at how we can move a relational database into a graph. Now, for this, I'm going to use the Northwind database as an example. If you've been learning Access databases or SQL Server, anything Microsoft related, chances are you know this. I remember this from my VBA days back in college. This is kind of the example that we would use. But actually, it's a really nice data set to demonstrate Neo4j and how Neo4j works. And what we're going to do really is we're going to work out how we move that data into a graph model, something that looks a little bit like this. In order, I guess if we take a quick look through the schema, the important tables that we have is obviously the customer is our most important thing here. The customer will place an order. An order has many products to it, so we have this order details link table in between to represent the many-to-many relationship. Orders are placed by, or I think facilitated or by an employee. A shipper will ship that order, and then we go from there. So typically what would happen is you would use the table names in the database to become the labels that you identify nodes by. So in this case, we have the majority of these tables. So the customer, the order, the products, the suppliers. I personally bring these in and make these the singular of it. So we have order, product, customer, these are then what we use to create the patterns in our data. So a supplier will supply a product, a customer will purchase an order, and a shipper ships an order. And so I guess another thing to kind of notice at this point is that we have, in a relational database, we have these foreign keys to represent the corresponding row in a corresponding table. Now, we don't necessarily need to do that inside Neo4j. We can store a foreign key or the ID of the the node at the other end of the relationship if we want to, if it makes things quicker. But really, we don't really need to. We'll use the power of a graph database to traverse and expand through these relationships. So that's something that we don't necessarily need to store. And the benefit of this, instead of having like a supplier ID in a products table, for example, here, which represents that join, we can use a more user-friendly term for that, like a more natural term for that, for the relationship between the two. So a supplier supplies a product, a customer has purchased an order, and a shipper will ship an order. So for me, that's a key benefit. Rather than, I guess, like a lot of times you have these inventive foreign keys that you add in the table, or like one of my favorite things is like, category ID 1, category ID 2, when you're linking two categories together. What does that number actually mean? But actually, in this case, you can supply context through the relationship type that you use. So maybe that's the parent of, that's the child of, whichever way you want to model it. And then, so many-to-many relationships. I kind of touched on this already, but this is a key thing. So when you model data in a relational database, you kind of get these unnatural tables that represent the many-to-many relationships. Now, in this case, we have an order can contain more than one product, and a product will appear in more than one order. So what we do is we have this table in between, which has the order ID and the product ID as foreign keys. And then in this case, we've got the unit price, the quantity, and the discount as properties on that table. Now that's fine. That example makes sense. But if we take a look at this one, we also get some inventive like table names that come up, basically because like it's hard to name things, right? Like it's we're all developers. We got hundreds of tickets to work through in order to deliver this project. We're not going to spend too much time working on table names. So I'm guilty of doing this as well. Like sometimes you mash together like the two table names together. So in this case, we've got the customer may appear in more than one demographic, and the demographic will have more than one customers. So in this case, it's a customer demo table, and that's fine. And like as the developer, as the person who wrote that code, I would know what that means. But what we're doing here is we're introducing technical debt, and then it may not be so obvious to somebody else what that table actually represents. And actually, when I looked at this one, it actually made me laugh a little bit. I have no idea why it would be called that, but that's the decision that they made. So yeah, mind blown. But what we can do in a graph database is we can provide a more natural modeling. So instead of having like this, or like a more natural naming, because instead of having this, I guess order details kind of make sense. But really what we're saying is an order contains one or more products. And then instead of having this kind of table in between that we have to insert data into, we just create the relationship between. And those additional properties on that table can be applied as properties against the relationship itself. Now let's take a look at an SQL statement to a Cypher statement. So answering the question on the please suggest a website for the Northwind data. So there's a little link down here. But what you can do is you can search for a Northwind example, Northwind database example, and it will give you plenty. Like, I mean, if this example's been around for 20 years or so, maybe longer. So there's plenty of resources out there. So one of the things that I found just by Googling it was this link here, which then gave me an SQL statement for, I think this was produce. I think this created a view for the order and product details. But so left-hand side we have the SQL query, and then on the right-hand side we have the corresponding Cypher statement. So instantly you can kind of see that the query is shorter, which I definitely prefer. And the key thing really is in the from clause. So let's take a look at here. So like in an SQL statement, what you do is you define the select up front. And now I'm a lazy developer, I guess. When writing SQL statements, I rely on the IntelliSense and the suggestions for it. So what I would personally do is I would write select star from, and then I'd start to define my tables, and then that would allow me to get the autocomplete when I type o dot something. It will tell me all of the columns inside that table. But what you do in a Cypher statement is you will write the pattern up front. So you'll define the pattern. You'll define that structure of data that you're interested in up front, and then you do the return after that, which for me is one of those kind of like eureka moments. Like I've probably been writing at least a decade's worth of SQL by the time I came to Cypher. But it's one of those things. Actually, once I got my head around that it like why would you do things in any other way? But yeah, so the select clause and the return clause are pretty much identical here. There's a few changes here, so that there's no convert function like there is in SQL Server. I think that the example was here. So the extended price is calculated a little bit differently, but everything else looks exactly the same. We're using the reference of the table, and then the either the column name or the property name to return the data that we're interested in. Now, as I say, this is our join. This is our structured tables that we want to join together. And if we compare that to the Cypher on the right hand side, for me personally, this is a really easy thing to kind of reason about. So I can kind of see that the customer purchased an order, the order contains products, and then the shipper has shipped it. Yeah, and instead of having to build out and just typing stuff is laborious, right? Like we don't want to be doing that. Yeah, we don't have to type inner joins. We don't have to define the foreign keys that we're connecting on, because that's already baked into the database itself. Cool. In terms of the where clause, now there are kind of two ways that you can do this. So I've defined this inside the pattern itself. So this is option one. So we're matching a pattern with the data it's there. But we can also define that as part of the where clause. So where the c.customer ID is Anton, and then it's exactly the same. So what we're doing is where we're finding our data, and then we're filtering down using the where clause, which is exactly the same as we would do in an SQL query. I guess one of the real benefits of Cypher is that once I have this pattern and this data of this data that I'm interested in, where this kind of ends in a in an SQL query, and like you define the operation that you want to do up front. What we can do in a Cypher query is we can chain more things onto this. So maybe we can add another match clause, or we could do some sort of write operation in there, or we could run a procedure, or we could do things sequentially, and actually we can process the data inside SQL, inside Cypher rather than being kind of confined in an SQL query as to what we can do. Cool. So Sid, are there any questions at this point before we move on to the next section?
Well, we have a couple of questions. Okay, the first question is, what is the data modeling tool popularly used for knowledge graph?
So we have, so I guess two options really. So there is arrows.app. So if you just want to model out some data, and you kind of want to do a more of a conceptual model, then I would suggest arrows. So this allows you to, I mean, I've been playing around with football data recently. This is the last thing that I worked on. I mean, you can just kind of start to draw things out. So let's say, maybe we have a person. Who's acting in a movie, and then we can start to kind of like define what we and what we're interested in, and then that's more of like a I guess so. I don't think we've got a proper name for this, but I call this like an instance model. But we're actually defining the info or the information about the nodes that are in there. If you have, like, for example, like CSV files, what you can do is you can go into the import tab inside Workspace. So I've got, these are my instances here. If you click open, once you've created an instance, then you get sent to this is called an EFJ Workspace. And inside the import tab, you can import CSV files, and then you can actually define the model inside there. So I think it depends on whether you have the data there already or whether you just kind of want to play around. I would say either use arrows or use EFJ Workspace.
Super cool. Thanks, Adam. I think that answers. The next question is by David, and he's asking, what's the underlying decision that dictates the creation of an intermediate node?
So that is really if you want to add more more context to a fact. So in the example I had, a customer can order a product, and that might be enough for the use case just to have a relationship between the two. But there's actually more information that we need to store about the order itself. So, for example, who shipped it? An order is actually a grouping of products. So you have to you kind of have to have that node there in between the two to allow you to link to the different facts. Yeah. Whereas I try and think of a different example. But it's really if you want to link a fact to other things, then you would have the intermediate node in between. It may also be the case that you have a node for grouping, for example. So we have an example somewhere with like logistics and routing, or like a flight examples, and it may be that you group so you could have like the flights as a relationship between two airports. And I mean that might work, and then if you have the relationship between the two, the relationship could be the flight itself. I'll tell you what, let's draw this out. So we've got airport 1, and then airport 2. So it might be good enough just to say there is a flight between the two, and then that has a flight number of BA1234, let's say, for example. But the problem is when if you have too many of these relationships between the two nodes, your queries are going to be less performant. So the key to writing a performance Cypher query is that you look at a smaller amount of the graph as possible. So say we had flights out to all these different airports. In this case, we have to follow like all 6 relationships out to find that if the airport on the other end is the one that we're looking for. And then if you think about, we've got onward journeys, that it's going to become quite a complex thing. And it may be that, we may want to know that flight is operated by a certain operator. So what we could do then is say that, let's say we have a flight which departs from one airport and then arrives at the other. And then we can say, this is then operated by British Airways, for example. And so I guess that's the first level of an intermediate node. But then if you want to find all of the flights that depart a certain airport on a certain day, then if you take somewhere like Heathrow or Frankfurt that have got hundreds of flights per day, that's a lot of relationships you need to check just in order to find the flights you're interested in. So you could do an extra grouping or an extra intermediate node between the two to say that these are the flights for let's call it an airport day, where the date is 2023 0601, and then we then we can group it from there. So instantly, instead of looking at thousands, tens of thousands of flights that come out of that airport, depending on how much data you store, you're then looking at the, let's say, 400 or 500 that go on that day. So yeah, hopefully that answers the question. Really, it's kind of like you will use a node, like an intermediate node, either to add some extra context to a relationship or something that you have in the graph at that time, or it's a way to cut down the amount of the graph you actually have to look at a particular point.
Cool. The next one is, I think, related to the first one, which is tool which does logical model transferring to physical model, creating DDL for Neo4j, reverse engineering from Neo4j. I think this is related to the data modeling tool.
Yep. Yeah, definitely. Yeah. So you can I think you can export this model as Cypher if you wanted to. But that's probably not the best way to do it. I think that the best way really is to use the import, convert your data into CSV and import it in from there. In terms of an actual a DDL, I think there's nothing that we have to offer that at the moment. But maybe that's something we can use ChatGPT to work out. So a good question. Something we should probably explore.
Cool. The next question is by Jersey, if I'm pronouncing the name right. In community version, is there a way to define stored procedures?
Now you stumped me because it's been a while since I've used Community Edition. So let me see if I can just find in the docs. It looks like it is possible. Yeah. So in order to build a stored procedure, so you write those in Cypher. You write them in Java and then you execute them in Cypher. So let me see if I can find an example. So the idea of a stored procedure is that you would you use it to either do something that's impossible to do in a Cypher statement, or something that is too difficult to express in a Cypher statement. So APOC is a great example of this. So APOC is the Swiss Army knife for Neo4j. If you need to do something, then chances are there's already a Cypher, an APOC procedure for that. But things like importing or like reading a JSON from an API is not possible to do inside Cypher natively, but we have a procedure that allows us to do that. And then the way that you would call that is you would do something like call apoc.load.json, and then we have the from a file, so that could either be a local file or HTTP. HTTPS, you yield the value, and then you have that value in Cypher, and then you can run it from there. So APOC is packaged up as a jar file. So once you've written your procedure, you package it up as a jar file, and then that's a bad example because that's the test. And yeah, so basically you write some Java code. That Java code then you apply like an annotation to it to say this is the name of the procedure. You then build the jar file, add the jar file to the plugins folder on Neo4j, on the Neo4j install, restart the server, and then in theory that should be there. If you go into the Java reference, you should be able to see more information about that. But yeah, they should be available for Community Edition.
Cool. All right. So the next question is by Ishwar. That's a bit lengthy one. Dear Adam sir, if you don't mind, I request you to one thing. I have taken one data set and did all in Jupyter Notebook with all pre-processing and built the ML model and reached out the target values. So after this, I want to build the graph model from Jupyter Notebook so that I have created some nodes and relationships, also pushing up to our sandbox. But here it's not created at all, and but not adding that particular data from the column. So what is the solution?
Good question. Hey Ashwa, how you doing? Yeah, I think it's hard to give a solution to that without seeing what's going on in the notebook, to be honest. If not all things are building, like I'd probably check the error messages to see what's going on there, see if there's anything going on. But in theory, once you have the data and it's all in a Jupyter notebook, you should be able to like load it into Neo4j transactionally using the Python driver. But yeah, without seeing the code, it would be difficult to diagnose. I think what I would suggest is if you could load that, put the examples onto GitHub or somewhere publicly where we can check it, and then post a message up on the community forum. So that's community.neo4j.com. Then
I would to say that it's better to put it on either the Discord or the Discord handle, any of those two places, so that we can actually look at what's going on. So if you can put in the steps to replicate, if you want to abstract it, that would be fine. Just abstract it and then put it in either the community forum or our Discourse forum, and we'll take a look at it.
Yeah, 100%. And then it's if not one of us from Neo4j, maybe somebody from the community will have a solution as well.
That's right. Cool. The next one is by Ishwar again. If you don't mind, if possible, can you share this material and GitHub link? I'll answer this one. So the material and everything. So this recording will be available on YouTube after the session is over. So you can revisit the session and go through the content again. The slides I'll check with Adam towards the end. If he's fine, we can put it slides on a drive and then post the link in the resources section of the description of this video.
Yep. Yeah, that's fine with me. Yeah.
Sounds good. The next question is by Bioni Chaos. Is there a Python extension for this? Which I'm guessing is there is one. A driver.
Yeah, I guess it depends what this means. For modeling itself, there are some kind of like packages. Like Pythoneo is one of them for kind of modeling things in like entities in Python. But yeah, I'd probably say check out the Python driver. That's the best place to start, and then everything else will build on top of that.
Super. The next question is by Ishwar again, and I think I'll probably defer this one and ask Ishwar to rather post it on the community forum because this is a little related to what he's already doing. Uh, just calling the question out. If we number of group names in one column, so then how can we show them with that groups individually with relation from the same column?
So I guess it's like a self-referencing table, I guess, like something like a community, like a category hierarchy or category tree or something like that. I think so. What you can do is say you've got a CSV, and then that CSV has 2 columns in there. So say we had like an array, it would be like category 1, category 2, category 2, category like 3, for example. Like if you had the those values in a CSV, you could just do like a merge category. The name is 0. Call that C1, or call that C2. So that'd be the first and the second values, and then merge C1 as child C2. I'm assuming that's what we're kind of looking at. But yeah, as long as you've got the inside the columns in the CSV file or some sort of reference between the two things, create a relationship between the two, and then in theory you just have to return that data back. So return all of the categories, and then the force graph layout will turn it into a tree in the FJ browser.
Gotcha. Cool. Thanks, Adam. There are 2 more questions. One which we already discussed at the very beginning, probably, and there's another one on the related topic on knowledge graph. Probably, I think we can take this up towards the end, and I'll let you continue with this.
Yep. Okay. Cool. Sounds good. So say we have I guess we kind of touched on this already, but say we've got a graph that's that we've modeled, we've worked through, but may not be as performant as we need it to be. Maybe we need to reach that arbitrary number that managers always like to do. It's always like 500 milliseconds for response time. Just plucked out of thin air because somebody else has said that they that their queries return in that time. Or we've got like a new use case that we need to answer. We can do this, perform this kind of process called graph refactoring. So we would refactor a model when the model that we have doesn't answer all of the use cases that we have for it, all of the questions that we need to ask for it. Maybe something new comes up, something gets added to the backlog to your development work, which we now have to account for in the data model. Or the Cypher, like I say, like the Cypher is just not performant enough, especially when the graph grows into, just grows inside. You add nodes and relationships, and all of a sudden, things aren't, as quick as they used to be. So there's a few methods that we have for refactoring and for speeding up our queries. So the first thing is to either create an index or constraint. We can add new labels to the database to slim down how many nodes we're actually looking for. We can extract a property of a node into a relationship, or we can use specific relationship types to slim down the number of relationships we actually expand during a query. So let's take a look at adding a label. So let's say, as a sales rep, I would like to recommend alternatives to discontinued stocks to ensure that customers have a viable alternative to their favorite product. So in order to add a new label to a node, firstly, what we need to do is we need to first identify those nodes. So in this case, we're using a match clause to find all of the product nodes where it has a discontinued property on there, which is set to true. We can then use the set keyword to add a new label to that node. And then once we've done that, we then measure the results. Is it more performant? Is it, does it do what we need it to? Okay, in that case, if it doesn't, then we have to go back to the drawing board. Otherwise, we're good. We can extract a property into a node, which allows us to kind of query through it. So let's say, for example, as an operations manager, I want to find all the customers that live at the same address, so we can optimize the delivery routes. So what we can do here is firstly we create the constraint on a new node called address, to make sure that the I guess in this case we'd use like a hash of the address details, or an array of the address elements to work out the uniqueness of an actual address. We then use a match statement to find all of the customers and their addresses, and then pull the address property from the node. And then we use a merge statement to either find or create an address node with the values from the property or properties, and then merge a relationship between the customer and the address nodes. And then we've got this model of customer and address. And then again, we would then measure the results on that, see if it works and see if it does what we need it to. Cool. So specific relationship types. So this is my favorite. I guess we kind of, I suppose we kind of touched on this already. But when you're querying a graph database, the more of the graph that you touch in a query, the slower the query is going to be. The benefit of graph databases is this expanding relationships or traversing relationships, and really what we need to do is we need to kind of slim down what we're the amount of nodes and relationships we actually touch inside the query. So the best way to do this is with specific relationship types. So let's take this. This is a customer profile. We've got the customer in the middle who has purchased a MacBook Pro, a Magic Keyboard, and then some Bose Quiet Comfort headphones, which are all electronics. They've got some checkered shirt and Converse high tops. Obviously they're a bit of a hipster developer, and I guess they also like to drink tea and beverages, I guess. But we have Chang and Chai in there that are both part of the beverages category. Now, so say we have a new use case come in, the head of electronic sales for the company wants to find all the customers that have purchased electrical items, and then maybe they recommend them similar products in order to boost their sales numbers. Now, so in this small case, it's not going to be too much of a problem because we're looking at 1, 2, 3, 4, 5, like 7 relationships. But if you scale this over, thousands, millions of customers, then this is quickly going to add up, and it's going to become a slow query. So what we can do is we can add, or we can encode information about the node on the end of the relationship into the relationship type in order to slim down what we actually query, or the number of relationships that we actually expand through. So we can maintain that purchase relationship because that allows us to answer one use case, and then add an additional one in there to say that for each customer who has purchased a product which is part of the electronics, we can encode the information about something further down that chain into the relationship type itself. So we've also got here purchase electronics, and then we've got purchase clothing, and then purchase beverages. And then that allows us to answer specific questions about the purchase history of customers. So so that allows us, so if we're looking just for electronics, we can just follow the purchase electronics relationships to find out what they've actually purchased. Another example I've got, this probably one of my favorite ones from my consulting days, was a customer in a bank may have many accounts. Well, those accounts have different types. That could be it could be an account for a credit card, could be a debit card, current account, it could be a checking account, or a savings account. So rather than just having a has account relationship between a customer and an account, we can actually say has a checking account. And then if you have this is like an example of 4, what you can do inside the Cypher queries, you can say follow the relationships where they are any of these, say 4 types. You use a pipe to say follow this or this or this. And then I guess in terms of this example, you may not want to do it that way, so you maintain the original relationship. But yeah, you can either say follow relationships of a certain type, or follow every relationship from node A to node B, and then check that node B's got the right right label on there. Cool. Okay. So that's the end of that section. It's really, I think, the end of what I have prepared. So if anyone's got any questions on Cypher, or any ideas of kind of Cypher queries that they're interested in looking at, or we can take an example scenario and move from there. Otherwise, I will play around until the timing's up.
Sure. There's one question. I think probably we can take this towards the end. This is not specific to Cypher, but more in general about graph modeling. You want to take up now, or do you want to take up later on?
Yeah, let's go now. Yeah.
Okay. The question is, what are some of the real-world benefits that can be realized by the sales department when they move their customer and client data from relational to graph?
Real world benefits. So I think that puts me on the spot a little bit, because I have to kind of put my mind in the put myself in the mind of a somebody who works in a in this domain. But I think so. One of the ones I touched on was like the recommendations. So like you're using the connections between customers and products to provide recommendations, or upsell and cross sell. These are the kind of things that really benefit from graph databases, and providing these things in real time is can definitely be a benefit. I personally, I get really frustrated when I get recommendations that, in theory, that you can kind of tell when you go on to I don't know, certain streaming platforms, that you have recommendations that are batch processed once a day. Once you're in theory, once you've generated those recommendations, like they are out of date. And then say I watch something inside a particular session, those recommendations don't get updated for me. So yeah, it doesn't take into account real-time context. Whereas if you do that inside a graph database, then then you can use that context to kind of drive further. So if you think of, like, you're going through like a website where you're shopping for something, you get people who bought A also bought product B, that sort of thing. Combinations of products that people have done before. Now those things can be batch generated, and that might be fine. But I don't know. Say one of the things that I find with the the online store that is named after a river. Where if I'm searching on there, there seems to be like a lot of like generic products on there that I can't quite tell the different, like based on things like customer ratings. I might be able to see which ones are the best, but you get lots of things that look similar or identical, but maybe different. And maybe as I'm going through those, if I go from one product to another, it recommends the first product. But what you could actually say is that the fact that I'm still looking and I'm not I've gone past that first product means that like intrinsically I've decided I'm not going to buy that one, so I don't want to be recommended that. So that should be excluded from my recommendations. So you can use kind of like the not only the previous history of other people, like the purchase history of other customers, to provide the recommendations. You can also inject that real-time context in. And really, I guess the golden rule is, like, anywhere where there's lots of connected data, or let's say from a technical point of view, if there's more than 3 joins, then your relational database is going to start to slow down. So same for NoSQL databases. Like if they're if there's like lots of joins there, if there's and the more that the database grows, the slower that's going to get, and you still have to compute those joins in real time. So anywhere where there's lots of connections. So in this case, like, if we look back to the Northwind example, where you've got customers who place an order, and then that order has a shipper, and then it also has a what else was there? The employee and the region, and like all these joins and these all of these the joins, that they all add up. So in order to kind of speed up the queries there, and even representing those queries in a nice way using Cypher is definitely a benefit. I can't think at the moment to kind of rattle off 4 or 5 examples for in a sales context. But yeah, I'm sure there will be. And to be fair, we've got sales guys, and we've got engineers that like field engineers, consultants, that will be able to answer that question a little better than me. So feel free to reach out, and I can send you in the right direction.
Great. Thank you. Thanks, Adam. And I hope this answers, Thomas, for you. We have three more questions, but those are very, very related to knowledge graph. I'm not sure if you want to take up, or we can rather push them to the next session that we are doing on knowledge graphs with ChatGPT. So, like your call.
Yeah, I mean, I can take a stab, but I know for sure it'd definitely be more beneficial if they tune into the next one.
Okay,
Yeah.
cool. The first one was how can you use knowledge graph capabilities in logistic world? Can we also optimize the whole structure to prove a recommendation to fulfill the demands at factories or hubs?
Yeah, I mean, so going back to the the stored procedure question, one of the things that you can do inside a stored procedure that you can't necessarily do inside Cypher is build out an algorithm that routes the allows you to route deliveries and to perform those kind of logistical type queries. So that's that's a key benefit. And then I suppose if you're adding the knowledge graph layer on top of that, you then start to kind of add more context, and then you can improve the way that routing algorithm works. So yeah, I think if you're looking at like the load of a driver, the type of vehicle that driver is driving, and the adding into that the context of when are those tires gonna need to be replaced, and all these sort of things. You can take all of these data, all these different data sources, put them in the same place, and use them to improve that that initial algorithm.
Great. Cool.
Yeah,
I'm
tune into the
guess
next one.
yeah, I guess Rohan, this answers a bit of it. But if you are looking for more elaborate answer to this, you might have to tune into the next session that we are going to do with knowledge graphs on knowledge graphs with ChatGPT. He has another question: is can we introduce some time component also in knowledge graph?
Yep. Yeah. So there's I guess that's a little bit of a modeling decision in general, really. Where you have these things that change over time, and maybe you have a graph that holds the versioning of of an item of a product of something, really, and maybe you're kind of tracking over time the the things that change. So yeah, we have date time properties. Yeah, I think it's five or six temporal types, and then we can calculate durations between the two. So you have that from that point of view. You have the time element, and yeah, I mean grouping nodes by date and time, depending on the use case, is also something you can add to add the add a little bit of context there. And like I guess like tracking changes over time. Another thing you can do is you can create like a they're called like linked lists. So you have like a next relationship between the nodes, and then you can see how these things change over time, and how like version A to version B, the changes, differences between those, how long it takes for a tire to degrade or whatever, like based on the service history. Every time the car, or the van, the vehicle has a service, you can track that through. And yeah, I mean, price changes over time is another one that you can do inside a linked list. So if you have a set of products that you're selling, and then due to inflation things change, you can track that over time as well. Yeah, it's all about just adding new nodes with either grouped by a date node, or by relationship type with the date encoded into it, or even by version number, and then yeah, you can create subgraphs that have the different the different elements that will change over time.
Correct. The next is a follow-on question on by the same attendee, Rohan. Do you have any resource on Bayesian-based knowledge graph? Wow, that's very
On
specific.
what base? Sorry, what was the
Bayesian,
base?
Bayesian-based knowledge graph.
Oh, patient. That's a good question. I personally don't. I don't have anything anything offhand that I can think of. But I think if you search for Neo4j healthcare or Neo4j graph, I know that there are ones out there.
Yeah, there's a very interesting article by one of our ninja who wrote like some time back. I'm just gonna share the link in the chat window. Probably if this helps. And let me also broadcast this over here. 1 second. Yeah. So this is by Dr. Shijing. He wrote this on how to build a Bayesian knowledge graph. Probably this should help. That's all I know.
Yeah, I know there's sources out there, but there's none on like the tip of my tongue for it. I think again go back to consultant answers. Like anything is possible. You can do anything with I like from a sales angle as well. You can do anything with Neo4j, but yeah, it's all about like identifying the connections between data and leveraging a graph to explore those in real time.
Cool. Sounds good. Yes, I think those are the questions. Probably you can continue from here.
Okay, cool. So I've got a couple of Cypher statements here that I can build out based on the Northwind data model that we work through. If anyone has got anything that they want to challenge in terms of a Cypher query, I think that could be fun as well. We can look at modeling and things like that as well. But yeah, I mean, so let's take a look at this one. I'm going to write out. I don't have the data set with me, but I can write out the Cypher. But we can take a look at, as a sales manager, how do I find the customers that have the highest spend? And we can reward their loyalty with personalized offers. So if you bear with me 1 second. Okay, so if we take a look at a basic data model and what we would have, the customer purchase and order. And then the orders one or more products. Oops, sorry, it's orders. Cool. So fairly simple. Nothing too hard there. What we want to do is we want to identify this pattern in the graph, and then what we can do is we can use the information on the order or the orders relationship in order to find the most active customers. And now this could be like most active customers in terms of number of orders in general, or maybe the people that have the most spend. It depends on how you'd want to identify that. But really what we're doing is we're using the match clause to identify the pattern. That pattern is for a customer who has purchased an order, and then that order orders product. And then, so once we've got that pattern, we can then use an aggregation to find out who is the most active customers. So we could say, return the customer ID And then we can say like product name. We can use like a list comprehension to get the categories that this product is part of. Then we can return the category name for that as categories. And then we can say count star as count. So this will give us for each customer and the product that they've ordered. It will give us the categories that product is in, and then the amount of times that they bought that. And obviously we can filter that down, so we can say where the product name is, I think neck oil was the one I had in the database. We can also filter this down by region as well. So say, so you have a customer who has an address which is located in a region, and then say we have a sales rep in there, so represented by. We could then filter it down to get all of the people that live in a particular employee. So we can say, where the customer has an address, and we can say, has an address in region. And then that will be so 2 degrees. So I could type this out as its own pattern, like I have done in the past, but I'm a lazy developer. I don't want to type too many brackets, so I can just say follow has address and in region relationships and outgoing direction to 2 degrees until we find a region node. And then we can say where that is represented by. Where the employee name is Sid, and then we'll get the values from there. So this is just doing a basic count there of the orders that we have. What we really want is to find the people that spend the most money. So what I can do is I can flip this around a little bit. So we'll move this bit up to the top match. And then we have the unit price and the quantity. On the order relationship itself. So we could say that with the customer and then the employee, and then we can do like an aggregation. Instead of a count, we can do a sum of the unit price times quantity as a total spend. And then we can say total spend or by total spend in descending order, and we'll take the first 10. So these are our top 10. Top 10 most active or most spending employees. We can get more complicated than that. So we could say where the product is in it's part of category with the category name electronics. Now, I mean, hopefully this is kind of demonstrating the power of Cypher and the things that you can do inside a Cypher statement. And really, what we're doing is we're just building up, and we're following through relationships until we get to the pattern that we're interested in. I mean, I'd like to see this side by side with the example from in SQL or in a like an SQL database, because I mean, to me, this seems so easy to do. Cool. Yep. So I guess we kind of cover that one as well. So the most active customers in my territory. Yeah, great point, David. Yeah, that is the response of how it could be used in a in a sales organization. Yeah, I think really like anything, you could. What I personally would do is I would just add the data in and then kind of play around with it to see what would be interesting. Maybe there must be some sort of driver for this. You could take a look at, have a chat with some developers or some people that write reports, some data engineers, to say like what are the slow running queries, and then work out which ones have lots of joins, and then see whether that can be improved in a graph. Cool. Okay. Yeah, so I think that's pretty much all I had kind of covered. If anyone, like I say, if anyone wants to shout, to give any, come back with any questions or anything like that, then feel free. The other thing I would suggest is that, so my day job is looking after a site called Graph Academy. So Graph Academy is where we provide free hands-on courses for customers, and hopefully everything I know will be here soon. But there's lots of resources for developers, for data scientists, to learn Neo4j. So the way that we structured it is there's a set of courses for beginners, which in theory everyone should need to know. So Neo4j's fundamentals, send that to your boss, and then he'll know what you're talking about when you talk about nodes and relationships. And then Cypher fundamentals teaches you the basics of Cypher, how reads and writes work. You can take a look at the data modeling fundamentals for working out, pretty much what I've covered today on what the what and the how and the why of modeling in Neo4j. And then the importing data course is there for importing data into Neo4j. And then we branch off into tracks. So there's lots of courses on how to do different things in Neo4j. So I definitely recommend checking that out as well.
Super. Thanks, Adam. I was in fact about to call out for Graph Academy. Well, folks, those are the amazing courses, and the man behind those amazing courses is with us, Adam. And of course, Ellen was there earlier, who was also supporting the curriculum, if I'm not wrong. If you want to continue your graph journey, you want to get onto those amazing courses, the URL is graphacademy.neo4j.com. Just go over there, start with the courses, go through the curated learning path, and of course take care, do take these certifications, the graph data science certification and certified professional certification. Again, 2 free certifications, and what's more is that once you do the certifications, you get a t-shirt at your doorstep. Nice, exciting. Okay, the next thing is I want to talk about Nodes 2023. Really excited to let you know that on October 26th, we are back again with the marathon of graph content. We're going to run this 24 hours back to back in all the time zones, APAC, EMEA, Americas. Make sure you submit your talks. If you have some exciting content to talk about, make sure you share those content, your talks by June 30th. So make sure you submit your talks. Okay, what's next is the graph database user group. So while we are doing a lot of in-person virtual talks, virtual sessions over here, we do a lot of in-person sessions as well. Uh, we have groups across the globe. So go to this URL meetup.com/pro/neo4j and connect with the group which is nearby to your region, wherever you are located. Okay, what's next is if you wish to speak at any of these meetups, in person, virtual, whatever you want to, just submit this quick form, dev.neo4j.com/submit hyphen your hyphen doc, and we'll get back to you as soon as possible and schedule a session with you. Next is about the Ninja program. Just few things about Ninja program. It's a highly curated program of graph experts, some folks who are really passionate about graphs and Neo4j and want to contribute to the ecosystem, share their learnings with the wider community. So we have this amazing platform for you. So if you are that person, make sure you apply for the Ninja program as well. Okay. Last but not the least, let's stay connected with the community. We have, as Adam mentioned this earlier, we have our website, community forum, community.neo4j.com, and also our Discord channel where you can post in your queries. So it's up to you whether you want to post in your queries. Go to dev.neo4j.com/chat and start chatting with us, or you can go to dev.neo4j.com/community. All right. Okay, this brings us to the end, and I'm super excited to uh, tell you about the session three that's gonna happen on June 14th at 10 a.m. IST. Uh, Make sure the time zones, timings for your time zone. We are doing this third session in the series, Knowledge Graphs with ChatGPT. Do join in. I have shared the link to register. It's also in the QR code, so you can either scan the QR code. Uh, yeah, that's pretty much for the day today and for this session. That's, thank you so much, Adam. It was an amazing one. Thank you once again for spending a time. I guess you're not in the APAC time zone, and it's great to have you over here. Uh, we are really privileged to have you for this particular session, and looking forward to staying connected with you and having you for the future sessions as well.
Yeah, 100%. Yeah, enjoyed it. And I've got so for all those people watching, so Sid originally scheduled this for 5 a.m. UK time, so I've got a definite appreciation of the kind of scale of APAC and the time zones. But yeah, as long as I don't have to get up at 4 a.m., then I'm more than happy to come and join you.
Yeah, I actually didn't realize that one, and I was actually planning to schedule it as per the Australia time zone, which is not too early for India, not too late for Australia. But then it ended up being too early for London time. But glad we could come to a mutual time. 2 p.m. IST, 7:30 Australia time. I think that's pretty decent. Hopefully, but the next one is happening in the earlier timing for Australia and earlier timing for India as well. So I hope that compensates for it. Cool. All right. Thank you. Thanks so much, Adam, and thank you everyone for joining in. Probably we'll see you next in the next session. Till then, stay safe. Take care. Bye.
Cheers all. Take care.